Is China's aviation engine technology truly viable? This question has perplexed military observers both domestically and internationally for years. It wasn't until mid-December 2025, when several high-definition photos of the WS-21 engine suddenly went viral on overseas military forums, that everyone was forced to reconsider. Has China quietly broken the engine technology curse, using facts to end long-standing biases and doubts? As a military weapons video blogger, who has long tracked global defense developments, I know full well that aircraft engines are hailed as the jewel in the crown of industry. Their immense development challenges often deter latecomers from pursuing them. Historically, Western discourse was saturated with pessimism, asserting that China lacked core technologies, and that its fifth-generation fighter would remain a pipe dream without foreign support. Yet the WS-21's unveiling pierced this fog like a silent blade, not only demonstrating solid progress in China's aviation industry, but revealing a transformative journey from follower to concurrent developer, and even partial leader. When close-up shots captured the intricate details of its serrated nozzle and smoke-free combustion, the global defense community was stunned, for this represents not merely a breakthrough in a single component, but the hallmark of a mature aviation ecosystem. Looking back, China's journey in aviation engine development has been fraught with challenges. Since the last century, international technology embargoes and market restrictions have long confined China to importing or reverse engineering jet engines, even leading to the embarrassing situation of having first-class airframes paired with second-class avionics and third-class engines. Acquiring advanced models often required bundled purchases of entire aircraft, leaving core technologies subject to external constraints, a pain deeply etched in the hearts of aviation professionals. Yet it was precisely this pressure that fueled the resolve for independent R&D. From the arduous beginnings of the Taihong engine series to the WS-21's stunning debut today, each step has been meticulously executed. Some may wonder, what makes the WS-21 so special that it has garnered such widespread attention? The answer lies in those circulating photographs. The engine nozzle features a precision serrated design that seamlessly integrates with the J-35's fuselage contours. This stealth optimization is not mere cosmetic enhancement, but a profound engineering achievement rooted in fluid dynamics and radar cross-section calculations, effectively scattering radar waves to reduce detection probability. What astonished Western experts even more was the near-invisible exhaust plume from the nozzle. This stems from the successful application of smokeless combustion technology, signifying substantial breakthroughs in China's high-temperature alloy materials, combustion chamber design, and fuel control systems. For fifth-generation fighters, infrared stealth is as critical as radar stealth. Smokeless combustion drastically reduces thermal signatures, making it difficult for enemy infrared detection systems to lock on, thereby enhancing battlefield survivability. These seemingly minor details collectively illustrate the transformative leap from quantitative to qualitative advancement in China's aviation industry. Technologically speaking, the WS-21 did not emerge from thin air. It represents a stealth-enhanced evolution of the WS-13 engine. This development strategy reflects pragmatic, long-term wisdom, prioritizing operational readiness over blind pursuit of globally dominant specifications to ensure timely combat capability. Recalling the J-20's development path, it initially used L-31F or WS-10 series engines for test flights and early deployment, upgrading to the mature WS-15 later. This approach prevented the project from being held back by engine development timelines, enabling rapid iteration of the fighter platform. Similarly, the J-35, as China's first stealth carrier-based fighter for the Navy, requires a reliable and stealthy power core. Although the WS-21's thrust specifications have not been fully disclosed by official sources, multiple analyses indicate its performance is sufficient to enable the J-35 to reach speeds of Mach 1.8 while meeting the acceleration and stability requirements for carrier takeoffs and landings. Such capabilities are more than adequate for missions like maritime patrol and rapid interception. More significantly, the manufacturing quality evident in the photos, smooth, even weld seams, uniformly applied thermal insulation coatings, and a compact overall structure, reflects China's advanced manufacturing sector entering a phase of standardized mass production. Historically, engine assembly relied heavily on the manual skills of veteran technicians, leading to significant quality fluctuations. Today, however, digital design and precision industrial processes have dramatically enhanced mass production stability. This systemic capability holds greater deterrent power than isolated technological breakthroughs, as it signifies China's ability to produce engines in bulk on demand, free from dependence on external supply chains. Turning our attention to the J-35 itself, The evolution of this fighter from a prototype to a core carrier-based combat asset best exemplifies the value of the WS-21 engine. Early speculation suggested the Air Force variant might utilize the more powerful WS-19 engine, but in reality, the WS-21 was the first to be installed and deployed, enabling the J-35 to rapidly complete testing and achieve initial operational capability. Its airframe structure has been reinforced for carrier operations, employing corrosion-resistant materials to withstand the high salt, high-humidity marine environment. The wings feature a flexible folding design to conserve carrier deck and hangar space. By the second half of 2025, the J-35 had completed electromagnetic catapult certification, signifying that China's carrier-based aircraft technology has caught up with international advanced standards, enabling it to compete directly with models like the USF-35C. All this hinges on the reliable power foundation provided by the WS-21 engine. As a domestically developed marvel, the J-35 carries not only military missions but also symbolic significance for national strategic projection. Its appearance on aircraft carrier decks triggers subtle shifts in the Indo-Pacific security balance. The introduction of stealth fighters compels neighboring nations to intensify investments in anti-stealth technologies and air defense systems. Meanwhile, China's self-reliance in R&D not only saves substantial funds, avoiding costly imports or technology lock-in, but also grants full control over production capacity. This strategic flexibility, allowing unlimited manufacturing, proves particularly valuable in today's geopolitical landscape. Western media reactions, shifting from initial skepticism to current admiration, validate the remarkable ascent of China's aviation industry. Experts who once declared China incapable of producing high-quality jet engines now must reassess their stance before the high-definition footage of the WS-21. This breakthrough is no fluke but the inevitable outcome of sustained investment. China has established a comprehensive industrial chain in aviation engines, systematically filling gaps from materials science to testing facilities. The success of the WS-21 reflects the quiet dedication of countless engineers and the sustained resonance of national funding and policy support. It underscores that technological advancement has no shortcuts, only steady, iterative accumulation yields results. This prudent path proves more fruitful than hasty shortcuts, for aircraft engines demand extreme reliability and durability. Any recklessness could lead to catastrophic consequences. Looking ahead, the WS-21 may not be the final destination. As development progresses on more advanced engines like the WS-19, the J-35's combat capabilities are poised for further enhancement, with optimizations in thrust-to-weight ratio and fuel efficiency. Yet regardless of how brilliant subsequent models may shine, the WS-21's legacy in Chinese aviation history remains irreplaceable. It stands as a pivotal bridge between past and future. Not only did it propel the J-35 from blueprint to battlefield, but it also bolstered the confidence of the entire industry. It demonstrated China's capability to independently solve high-end propulsion challenges, a psychological breakthrough that sometimes carries greater weight than the technology itself. For aviation enthusiasts, the WS-21, paired with the J-35, has become a new symbol of China's rise. For competitors, it sends a clear signal: China's aviation industry has crossed a tipping point and is steadily advancing toward the global top tier. In essence, the WS-21's debut not only dispels external biases, but also heralds a new era. Is China's aviation engine capable? The answer is etched in those smokeless nozzles and precision serrations. This is not the finish line, but a new starting point. As more innovations emerge, the story unfolding in China's skies will grow ever more spectacular. This leap has reshaped the technological landscape and redefined strategic dynamics. The WS-21 will forever be remembered as the milestone that shattered the curse and ignited confidence.